Trigonometry class, Chapter 1. In fact, we're in Lesson 1.2, which is angle relationships and similar triangles. So we're going to look at different relationships between angles, and you're going to see some commonality between them and things that you can determine based on where the angles are. So the first one we're going to do is take two lines and cross them. And we have a couple things that we're looking at. If you remember in the last lesson, if we took this angle and added them up, and they added up to 180 degrees, they were called supplementary angles. Any two angles added up to 180 degrees are supplements of each other. So that's something that you can learn, because then if you know what this angle is, you know that 180 minus this is going to be this angle. What else do we know? We know that if I hit the wrong key, everything disappears. So let's see if we can just do some re-racing here. Okay, we can't. Alright, so what we've got is an angle here. These two angles are called vertical angles. They're across from each other and they have equal measure. This angle and this angle are across from each other, or vertical angles, so they also have equal measure. That's a good thing to know for later on. And now if I want to look at two parallel lines are two lines that never cross one another in the whole history of the universe. They just go on and on and on, and the distance between them will always be the same. It never changes. So what do we do with parallel lines? Well, we're going to draw a pink line through here, and we're going to call that pink line a transversal. So when a line intersects two parallel lines, or even more than two, if we had a third parallel line, it'd still be a transversal. But let's just stick with our two right now. What we're going to do is we're going to get 8 different angles. We're going to get 1, 2, 3, 4, 5, 6, 7, 8. All right, there's some things we know about those 8 angles. We know that vertical angles are equal. So 1 and 4 are equal, 2 and 3 are equal, 5 and 8, and 6 and 7. All right, we also know that this angle and this angle will be the same as this angle and this angle, which means this angle and this angle are going to add up to 180. 3 and 4 add up to 180, 1 and 2, and 1 and 3. So we know a whole bunch of stuff just about those. We also know some things about these angles. One is called alternate exterior angles. Alternate exterior angles would be these angles right here, 1 and 8. We know that they're congruent to each other. We also know that 2 is congruent to 7. So that's one thing that's pretty important that we know. We also have what are called alternate interior angles. And we'll do that with, let's do it with green. We have alternate interior angles. Our alternate interior angles would mean that this one and this one are the same, and this one and this one are the same. So if we just know a few of these angles, we can determine what a lot of the other angles are. So alternate interior, alternate exterior, vertical angles, and the other one we're going to look at is corresponding angles. So let's see if I can get rid of these angles here, there. And let's look at corresponding. We'll do those in blue. Corresponding angles would be angle 2 and angle 6. Those are going to be the same angle. Angle 1 and angle 5 are the same. 3 and 7 and 4 and 8 are going to be the same. So, lots and lots of things you can get from that. One of the other things you can get from, I say the word things a lot, one of the other things that you can get from this transversal crossing two parallel lines is that interior angles on the same side of a transversal add up to 180 degrees. So if we're looking at an interior angle like this one and this one, if you add those up, you're going to get 180 degrees. And it's pretty easy to see that because this one and this one add up to 180, and this is the same as this, which this one is a vertical, so this one's going to be the same. So this is the same as 2 because of corresponding angles. 4 and 6 then are going to add up to 180, just like 4 and 2 would add up to 180 degrees. So lots and lots of stuff you can get just from that one transversal going through two parallel lines. So let's look at example 1. So we've got two parallel lines with a transversal. We've got line M and N cut by that red transversal, and what they want to do is find the measure of each marked angle in figure 15 given that M and N are parallel. So what we're looking at is we're trying to find out what this angle here is and what this angle here is. Now I know they're going to be the same angle because they're alternate exterior angles. But what are they? I know that they're equal, so I can write this as 3x plus 2 equals 5x minus 40. And I can do my math here. So let's subtract 3x here, 3x here. So I have 2 equals 2x minus 40. Add 40 to both sides. And I get 42 equals 2x, x equals 21. So if I put 21 in here for x, get my thing right, 21 here for x, so 3 times 21 plus, so 3 times 21 is 63 plus 2 is 65, so that's a 65 degree angle. And let's check it because they're both equal, so we could say they're both 65. So let's take 5 times 21 minus 40. So 5 times 21 is 105 minus 40 is 65. So both those angles are 65 degrees.